It's me, your host, Walter Wesley, on Short Attention Span Science. All right, properties of water. We're covering the three values of alkalinity, antioxidant, and microclustering. Today, we are going to do alkalinity and acidity, two very important concepts in water. And what I'm going to do is make some alkaline water and some acidity water for you at the very same time through the magic of science. All right, come on over here. This is called an ERW machine, electronically reduced water machine. All right, this is the only medical grade one available in the world. And anyway, we're going to turn this thing on here, and we're going to get two waters coming from the tap to this side, and the other one to this side. It's gone a little bit too fast for my likings there, but let's okay. So see, we're making two waters from the tap water. We're making an acidic and an alkaline water at the same time. Okay, now I'm going to turn this off and do some more science magic for you here. So I'm going to take one of these waters from here, one of these waters from here, and you notice they kind of look the same. All right, the same bubbles, same color. Okay, I'm going to take some special phenolphthalein that shows you the difference between these two different waters. Here we go. This is alive, so this water turns a kind of a yellowish, orangish. And this water, boom, a purple water, purplish water, right? Okay. So let's stir that up with that. Stir that up a little bit like that. Stir that up a little bit like that. Okay, so what's going on here is with that's what you're seeing here is acidity and alkalinity. Okay, really quick, because this is short attention span theater, all right? If I haven't lost you already, this is the difference between alkalinity and acidity here, this word right here. All right, if you draw it out here, 7 is on the bottom here, and 1 is over here, and 14 is over here. This is known as the pH scale. pH scale. Yeah, I think they make a small p and a big H like that, right? Okay. So, and it goes from acidity, and I'll use a yellow marker out here. Acidity is from 7 to 1. 1 being very, very acidic. And it goes increasingly 7, and this is important to remember, 7 is neutral. So I'll put in there, if you can remember, that's neutral. And what happens is over on this side here, and I'll grab this one, we have alkalinity over here on this side. So don't mean to bore you or anything like that, but this over here is concentrations of this thing called an H ion, and hydrogen ion, and it goes up to from 1 down here to 10, 100, 1,000, 10,000, 100,000, 1 million, up to here. And this is on a logarithmic scale, so 10, 100. That's what that means there. This over here is alkalinity this way on this chart. So it's kind of part of the same thing. You've all seen that, alkalinity, acidity, pH scale. Well, over here you get a more acidic liquid the further you up, and it has kind of numbers associated with it, 6, 5, 4, 3, 2, 1. And as you get more and more acidic, you get more and more hydrogen ions, and so that makes it more acidic. Over here, you have alkalinity scale going to 8, 9, 10, 11, 12, 13, 14. And then up here you have parts per million of these OH negative. And those are important. Two things important, I'll write them down, is this has more of these OH negative. I'll tell you what an ion is on my next mini lecture here. But this has more OH ions, and this has more H positive ions. And we use this scale because if it didn't have this scale, it would look like this. You know, never touching there. But the logarithmic scale, it goes like this. It goes like this, up to parts per million, which would be a solid H positive. No container can hold it. But as you go up here, you get more and more and more acidic. As you go up this value, you get more and more concentrations of ions on that. And as you go up this way here, on the alkaline scale, it's the same thing. As you go up, you get more and more alkalinity. So water can be both alkalinity, and it can also be acidity as well, too. So that's the pH scale. That's alkalinity and acidity, and this sort of shows the machine that makes it. This also shows the sort of the proof of what that ion is because of the phthalene, the solution. The other things I want to say about it is your blood level is always right in 7.2, 7.3, right in here, and your body does a lot to keep it that way. And gall and pancreatic fluid, I believe, are in the 8, 9, or way up here in 8, 9, and 10. Things like soda pop and even carbonated drinks are way up here in the 2.5, because anything with those CO2 bubbles that you drink, beer, carbonated waters, soda pop, instantly turn any alkaline substance into acidity. And I'll show that to you real quick right now. This is a little I won't even show this is a health water I used to think was really healthy and everything like that, until I learned about alkalinity and acidity. Because if I take an alkaline water like this and put just a little of this carbonated water, it's a great brand. I mean, I love the brand, but here's what it does. So that's what it does. Those are the results. Science there, making no claims. All right, but anyway, so that's it. Basically, on short attention span theater science, properties of water: H2O, alkalinity, acidity 7 through 1, alkalinity 7 through 14. All right, that's it. Have a nice day. I'm Walter Wesley. Thank you. Please leave your comments below, good or bad. We love to see them. It all helps me. All right. Like or dislike, thumbs up, thumbs down. It's all okay. I won't hold you responsible for that. All right. Have a nice day.